Section 1, Video 3. So let's apply some of the things we've just learned to shapes. Now in example 1, they tell us we have a trapezoid. And by definition of a trapezoid, we know that we have one pair of parallel sides. So keep that in mind as we go further, because we'll need those properties of parallel lines to help us. They give us angle y, which is right here, and they say that that is equal to 3x plus 19. They give us angle x, and that is right there, and that is x plus 1. And if the two red arrows here represent parallel lines, this is a transversal, which makes these two angles same side interior. In other words, same side supplemental. So we know that if we took angle x and added it to angle y, we would have a supplemental relationship because they are same side interior. Now instead of x and y, we want to use x plus 1 and 3x plus 19 because that's what each angle represents. And this is our equation that we would solve. Now the algebra I'm not concerned about. I know you guys can do that, so I'm going to do this kind of quick, but here's your equal sign. These are on the same side of the equation, so like terms is 4x. These two are like terms, so plus 20 equals 180. So 4x equals, take away 20 from both sides, and we get 160, and divide then by 4, and we get 40. Now this is what x represents. Be careful to represent the answer properly, because they said find the measure of these two angles. So we have to then take it and plug it back in. So angle y, if we plug 40 in for x right here, we get 3 times 40 plus 19, which would give us 139 degrees for y, and then, so 139, and x would be 41. Doesn't make much sense because one looks acute and one's obtuse and it doesn't quite work out, but in terms of their statements, that is correct. The next one we have is again a trapezoid. So we have the arrows given to us, which is nice. We have one correction to make though. This should be angle OLM. Okay? So do the following measurements make this figure a trapezoid or not? Well, again, to be a trapezoid, we have to have those parallel sides. So let's check our numbers. LMN is 133. OLN is 47. OLN. But like I said, it was OLM, so that's not quite right there. So LOLM is 47 right here. MNO is 111, and then NOL is 68. Now again, if they are truly parallel, then these two are same side supplemental, and so are those two. So we check that, and angle M plus angle L is equal to 180. That's these two, so that works. We check angle O plus angle N, and we get 179. That's those pair. So we would say no. In question number 3, we are given that WX is parallel to ZY. And we are given that WZ is parallel to XY. Name this figure and solve all the remaining sides. Now we have two pair of parallel sides, therefore this is a parallelogram. That's the abbreviation that I use for that. If that is the case, based on that information, then we can make statements that opposite sides are equal in length. So that means WZ is 250 because opposite sides are equal length. Therefore, WX is equal to 120. So we're utilizing this information here. Then we have angles. Well, we are told that opposite angles are equal in measure with a parallelogram. So angle y is equal to 110. And then the other two, well, we know that in parallelograms, these two angles are a part of the parallel sides and a transversal, so they are same side interior. And these two are same side interior, all because they are between parallel lines. So angle Y, we've already done, sorry, angle X and angle Z are both equal to 70 degrees.